In today's lesson, we'll be learning how to graph quadratic relations in standard form. You learned previously that a linear relation could take on two forms, either standard form or slope-intercept form. Standard form didn't really tell us much about the linear relation, whereas slope-intercept form tells us the slope as well as the y-intercept, making it much more useful. In this unit, you'll learn that quadratic relations can take on three different forms: standard form, vertex form, and factored form. Today we'll be focusing on standard form. When you have a quadratic relation in standard form, the easiest way to graph it is with a table of values. In our first example, you can see that we have a quadratic relation in standard form. Let's just label that standard form. We want to graph this quadratic relation by filling out this table of values. So let's go ahead and do that. I'm going to zoom in and we're going to fill out this table of values. So I'm going to take these values of x and I'm going to substitute them in to this quadratic relation. And that is going to give me an answer, and that answer is going to be my y value, which gives me a y and x value, which gives me a coordinate. Let's begin by substituting in this value of -3. So instead of writing x, I'm going to write -3. So -3 squared plus 2 times -3 plus 1. -3 squared simplifies to +9. Positive 2 times -3 is equal to -6, and the plus 1 stays exactly the same. So 9 subtract 6 plus 1, pretty simple, that is 4. Let's do this again with -2. So I'm going to put -2 in brackets, I'm going to square it, then I'm going to take 2 multiplied by -2, plus 1 stays exactly the same. -2 squared is +4. Positive 2 times -2 is -4, and that plus 1 stays the same. So 4 subtract 4 plus 1 is 1. Let's go ahead and do that for -1. -1 squared plus 2 times -1 plus 1 is equal to 1 subtract 2 plus 1, which is equal to 0. Let's do this for 0. I'm going to put that in brackets, I'm going to square it. 2 times 0 plus 1. 0 squared is just 0, and 2 times 0 is 0. That plus 1 stays the same, and I'm left with an answer of 1. Again, let's do this for +1. So +1 squared plus 2 multiplied by 1 plus 1. 1 squared is 1. Positive 2 times 1 is 2, and I have a plus 1. So 1 plus 2 plus 1 is 4. Let's do this for 2. So 2 squared plus 2 multiplied by 2 plus 1. 2 squared is 4. Positive 2 times 2 is 4, and plus 1. 4 plus 4 plus 1 is 9. And last but not least, let's do this for 3. 3 squared plus 2 multiplied by 3 plus 1. 3 squared is 9. Positive 2 times 3 is 6, and that plus 1 stays the same. So 9 plus 6 plus 1 is 16. So what we have now are a series of coordinates. We're going to plot these points. Let's take a look at the graph that we have. Let's graph these points. Our first point is -3, 4, which is right over here. Then we have -2, 1. Then I have -1, 0. I have 0, 1. And I have 1, 4. And I also have 2, 9. and I have 316. But since I do not have 16 on my y-axis, I'm going to leave it out. What you're going to do now is you're going to connect these dots with a curved line, and that will create what we call a quadratic relation or a parabola. Now, before we finish, let's go ahead and label some of the important properties of a quadratic relation. Over here at the bottom, you have the vertex. Since the vertex lies on the x-axis, that also doubles as the x-intercept, because the x-intercept is the point at which the quadratic relation crosses the x-axis. In this case, it's not crossing it, but it is touching it. And then over here, we have the y-intercept. Remember, the y-intercept is the point at which the quadratic relation crosses the y-axis. And let us write in our axis of symmetry. Remember, the axis of trisymmetry crosses the vertex. So I'm just going to draw that. And instead of writing axis of symmetry, I'm just going to write AOS. And if you really want to, you can say that this quadratic relation opens upwards. So I'm going to write that on the side. Opens upwards, and there is a minimum since the vertex is at the lowest point of the quadratic relation. And in this situation, the minimum appears to be 0. And there you have it. We've just graphed a quadratic relation in standard form. Don't forget that you need to use a table of values before you can graph these points.